Hello everybody, welcome to the first video of AlgebraCloud. In today's video we're going to deal with integer exponents and the rules that fall underneath this section. So you should try to remember that there's a zero exponent involved and also the negative exponent. For the zero exponent it's fairly simple. Whatever number or letter raised to the zero power is always equal to 1. So there shouldn't be any problems with zero exponent. Now for the negative exponent, there might be confusion on how to set this up, but always try to remember that x to the negative n, where n is any integer, is always equal to 1 over that number or letter raised to the positive integer of this. So an easy way to remember this is to say that, imagine this is the numerator already, and we're trying to shift this down towards the denominator. So in essence, we just want to bring this whole entire term down to the denominator, and there will be a 1 left over on top for the numerator, and all you need to do is switch the exponent in that letter or number raised to that exponent. And so to show that, I'm probably going to do a couple of examples with you. I'll start off with the zero exponent, and in case 1 we're asked to simplify it, so we have m to the 0 power, which is always equal to 1. It could be a letter or a number, it doesn't matter, and it could be 1,000 to the 0 power and it'll still be 1. So this rule should be fairly simple. So 12 to the 0 power equal to 1. Now there's different forms that you could probably have a base in, so always try to remember that whenever you see a parentheses and you see an exponent raised to that parentheses, that exponent applies to whatever is inside the parentheses, nothing that's outside. So right here we have a fraction. We have 2/5 raised to the 0 power. So we should automatically know that whatever is raised to the 0 power is always equal to 1. Now for this one, remember I just mentioned that whatever the 0 power always applies to whatever is inside the base. And in this case we have the parentheses. So whatever's inside the parentheses applies to the 0. Now this negative outside the parentheses we don't need to worry about, because it's not part of the base. So right here would be 1, and don't forget the negative. So it will be a negative 1. Okay, so let's just continue. Well, we need, in order to case 3, we should know practice the negative exponents. So for negative exponents, it's fairly simple. You just need to, for case 1, we have 7 to the power of negative 3. So we have this as a numerator already, and you want to bring it down to the denominator, and it would be equal to 1 over 7, and then you change the sign of the exponent, so it'll be 3. So 1 over 7 to the power of 3. Now our next example we have negative 5 raised to the negative 3 power. So remember I was telling you back over here that whatever is inside the base is applied to that exponent? Then right here, this negative might throw you off, so always try to remember this exponent applies to this base right here. If it would look like negative 5 to negative 3, then it will apply to the negative. But in this case we don't have it. So we bring it down 1 over 5 to positive 3. Don't forget the negative in front, so it will turn the whole entire thing to a negative. Okay, so pretty much that's pretty much the simplest negative exponents you'll probably see. Now for case 2, you notice that we have 3w to the negative 3. Then remember I was mentioned over here that this negative isn't part of the base. It's the same case over here. We have a 3 in front of the w raised to the negative 3 power. So the negative 3 power only applies to the w. So as we follow our rule up here, we have 1 over w to the 3 power. And remember, you're multiplying by 3. So in the end, it will be 3 over w to a 3. Now, let me see. Try to get that more of an angle. Okay. So over here, we have 4x to the negative 3 power, no, negative 2 power times m over 5. So what could we move here? Now notice your m is already a positive, so there's no need to move it. But this this x to the negative 2, we need to move that. So we're just moving the x to the power of negative 2, and we're only moving that. We're not moving the 4 or the m. We're just dealing with this term right here. So we just move it downward to the exponent, and left over on top we have 4m times, over 5 to the x squared. And that's it. If you're confused on how I reached this point, then another way you can say it is what's left over on top, 4m over 5 times. And we already know we already know that x minus 2 equals, according to our rule, 1 over x squared. So we could just multiply that across. We have these two fractions that we could just multiply across in this direction. Then we have 4m over 5x squared. Can everybody see that? Okay. Alright. So going back to our case 3s, whenever there's multiple variables involved, always try and look for the zero exponent, since it wouldn't change the answer in the end, since it's just 1 multiplied by whatever is also in there. Then we have a0 m to the negative 3 power over 5 x to the power 4. If you notice first that we have the a to the 0 power, so that would just be 1. And then we have the m to the minus 3 power. We could just leave it there for now. Over 5x to the 4. I'm just showing you what kind of steps you should take. But if you already know if you're able to do both of these at the same time, then that's awesome. So you have, and then the next step is that you notice that we have m to the negative 3. So we don't want a negative exponent at all in our simplified form. So our next step right here is to move it down to the denominator. So we have 1 over 5 x to the 4 m to the positive 3, and that will be our simplified form. Hopefully everybody can see that. X m to the 3. Okay, so in our next case, it also involves zero exponents and negative exponents. But if you notice that we have a negative exponent in both the numerator and the denominator. So if we've been moving a negative exponent from the numerator to the denominator, then whenever we have a negative exponent in our denominator, then we're going to move it to our numerator. So I'll just show you that right now. So we have c. We're going to move this b, c to the 3 power, over a minus 2 times. And always remember that try and look for the zero exponent, which just right here in this case will be 1 times. And we move this b to the power negative 5 down, so we have b to the 5 power. And so right there would be c to the power of 3 over a minus 2 to the power of negative 2 and b to the power of 5. And right here we have a to negative 2 in the denominator. Then we want to move it all the way up to the numerator. We're not dealing with the b to the positive 5, we're just dealing with this term. So we have a squared c to the 3 or b to the 5. And that will be our simplified form. And that pretty much concludes our video for today, and hopefully everybody has a brighter idea of what we're doing. Alright, thank you.